This is Workbook 5.3. We didn't finish going over them in class, so I just wanted to get a recording for you guys in case you wanted to look it over. So what is the value, or sorry, number one, what is the value of the expression 3 to the 1/2 power times 8 root 3 over 2 divided by 6 minus 1? So with these problems, we just really have to take them piece by piece. We're following order of operations as we go along. So the first step in order of operations is to check for parentheses or other grouping symbols, which other grouping symbols can be like brackets or it can be fractions. So we do have a fraction here, and we can actually kind of reduce and simplify that fraction. So the first thing that I notice is that 8 and 2 both have a common factor, so we can go ahead and actually just divide the 8 by 2. So the rest of the problem I'm just going to copy down. So it would become 3 to the 1/2 power, and then 8 divided by 2, that's going to become 4 times the square root of 3. So we just divided the 8 by 2, and then notice we don't change the 3 inside the radical. Any number inside the radical is like going to stay the same if you're just dividing by kind of a regular number that is outside of the radical, like this 2. And then the rest of the problem, I'm just going to copy down. So divided by 6 minus 1. And something that I don't really like dealing with problems is when I have some parts of the problem that are in rational exponent form and some parts of the problem that are in radical form. So we want to get them in the same form, and that's when you have to use the formula where it's like b to the e over r becomes the r root of b to the e power. And I think that's from like lesson 2 or lesson 3 maybe, if you want to look back at it. But I'm just going to go ahead and I'm going to put the rational exponent in radical form. And there's really not like a correct or incorrect way to do it. It just really comes down to personal preference. So anything to the 1/2 power is the same thing as like the square root as, but if we're using this formula, just in case like you kind of forget that the 1/2 power is the square root, my b is 3, that's the base. E is the numerator, so that's 1. R is the denominator, so that's 2. So we would draw a radical, and then the 3 would go inside of the radical, and then since the root, that's the index, so that's a 2. And when we have a square root, we don't actually need to put that 2 there. And then my exponent is 1, but if I have something to the first power, I don't need to write that exponent either. So notice like 3 to the 1/2 power is the same thing as the square root of 3. And I'm just going to copy down the rest of the problem. So times 4 times the square root of 3 divided by 6 minus 1. And then now I have some multiplication and division and then subtraction. So multiplication and division we'd have to approach next. We would go left to right. So my multiplication comes before my division. And then technically this whole thing is being multiplied together because this is like a 4 times root 3. And then what's kind of cool is multiplication is called, we can use something called the commutative property, and that just means that we can rearrange the factors. So I can actually rearrange this with the 4 in front and then the 2 root 3's next to each other. And I think that makes it a little bit easier to see how we can simplify for the next step. And then I'm going to bring down my divided by 6 and then bring down my minus 1. So now if I have the square root of 3 times the square root of 3, I can multiply those two together first. I can leave the 4 out in front. But if I take a number and I multiply it by itself, I'm squaring it. So the square root of 3 times the square root of 3 becomes the square root of 3 squared. Anytime you take a number and multiply it by itself, you're squaring it. Bring down the rest of the problem, divided by 6 minus 1. And then remember that squared, like exponents, like the second power and a square root, are inverse operations of each other, so they cancel each other out. So I would just be left with that 3 that's inside of the radical. So this would become 4 times 3 divided by 6 minus 1. And then now I can just go ahead and multiply the 4 times 3. So 4 times 3 is 12 divided by 6 minus 1. And then I can do 12 divided by 6 as my next step. 12 divided by 6 is 2 minus 1, and then 2 minus 1 finally is 1 for our final answer. Okay, so our final answer is 1. It could be in a different spot on your answer choices, but you should end up with 1 either way. And then number 2, what is the value of the expression 4 to the 1/2 times 2 over the 4th root of 16 minus 10 divided by 2? So same kind of like issue we have here. So with this problem, we have like rational exponents and we have roots. So I kind of want them to be in the same form. So I think in this case, I'm going to go ahead and change my radical into a fraction exponent form, a rational exponent. So using that same formula, this is my R is 4, my B is 16, and then there's no exponent, so E would be 1. So I'm going to copy down the rest of the problem to be 4 to the 1/2, and then times 2 over the 4th root of 16. It would change into, I just realized something. So it would change into 16 to the 1/4 power technically, but I forgot that you can simplify the 4th root of 16. So we're just actually going to do that instead of changing it to a fraction exponent. So instead of 16 to the 1/4, the 4th root of 16 is a whole number. It's something that we can simplify. So if I have the 4th root of 16, that's asking what number to the 4th power equals 16, which if we take 2 and we multiply by itself 4 times, that'll equal 16, because 2 times 2, that's 4, times the third 2 would be 8, times the fourth 2 would be 16. So the 4th root of 16 would be 2, and that's something that's much easier to deal with than 16 to the 1/4 power. Okay, so we're swapping out for the 4th root of 16 for 2, because that's what it simplifies to, and then I'm going to bring down the rest of the problem, so minus 10 divided by 2. And then our next step that we can kind of simplify is our grouping symbol, which we have this like 2 over 2 that's a fraction, so I can go ahead and simplify that. So 4 to the 1/2 times 2 over 2 is 1 minus 10 divided by 2. And then if you're looking at this, or excuse me, let me backtrack a little bit. So we don't have any more parentheses or grouping symbols or anything, so our next like step in order of operations would be exponents. And we have this 4 to the 1/2 power, and remember, if you're not really sure what to do something with like a fractional exponent or a radical, sometimes like just changing the form of it can give you a fresh look. So if I wanted to put this as a radical, the B would be 4, the E would be 1, and the root would be 2. So it would be 4 inside the radical, and then my root would be 2, but if it's a square root, I don't need to put the 2 there. And then my exponent would be 1, but if the exponent is 1, I don't need to put that. So 4 to the 1/2 power is just the square root of 4, which that's something we could definitely find. I'm going to copy down the rest of the problem. So times 1 minus 10 divided by 2. And then we're still in that like exponent step of simplifying, just because exponents and radicals, they both go in that second step. So now we can just simplify the radical. So square root of 4 is 2, copy down the rest of the problem, so times 1 minus 10 divided by 2. So now we're moving on to the third step of the order of operations, or PEMDAS, which is multiplication or division, and we just go left to right. So the first like multiplication that we see is this 2 times 1, so I'm going to do 2 times 1, which is 2, and then copy down the rest of the problem, so minus 10 divided by 2, and then we still have some division left that we need to simplify before subtracting, so we'll simplify this 10 divided by 2. So I'm just going to copy down the 2, and then minus 10 divided by 2 is 5, and then 2 minus 5 is negative 3. So final answer for number 2 should be negative 3. And then number 3, what is the value of the expression 27 to the 1/3 over the square root of 4 minus 3 times 6 to the negative first power plus the fourth root of 625? Okay, so this one has a lot of funky different things going to have the fraction exponent, the radicals, the negative exponent, so we'll just go piece by piece. I'm going to do my next line over here to the right. So we talked about this, I think, in the 5.2 workbook, but 27 to the 1/3 power is the same thing as the third root of 27, which that's something that we can simplify. So these two are the same. And the third root of 27 is asking what number to the third power equals 27, and it's 3. Because if we do 3 times 3 times 3, well, the first two 3's multiplied together is 9, and then times the third 3 is 27. So the third root of 27 would simplify to 3, so I'm just going to go ahead and replace 27 to the 1/3 power with 3, because that's what it simplifies to. And then over the fourth, or sorry, just the square root of 4, excuse me. We can just go ahead and simplify that. The square root of 4 is 2, so I'm going to drop a 2 down here. And then I'm just going to copy down the rest of the problem as is. I think that was enough for the first step. So next would be the minus 3. So minus 3, and then times 6, the negative first power, and then plus the fourth root of 625. And then the fourth root of 625, you probably don't know it off the top of your head, but you can guess and check it. So for the fourth root of 625, it's asking what number to the fourth power equals 625. And you can just kind of play around with some different numbers. You can use a calculator, but like if I did 2 times 2 times 2 times 2, that's definitely not it. That's 16. I'm gonna jump to, if I try like 4 times 4 times 4 times 4, I think that's 256. And then I'm gonna try 5 times 5 times 5 times 5, that is 625. So that means that 5 to the fourth power equals 625. So the fourth root of 625 is 5. So we can replace that whole thing with just 5. So I have 3 over 2. I'm just going to copy down the rest of the problem as is. And then minus 3 times 6 minus 1 plus the fourth root of 625 is 5. And then I still have, we simplified a radical there. I still have one exponent to worry about. I have this 6 to the negative first power. So remember, when we have a negative exponent, we have to like flip its base. So I can think of this 6 as 6 over 1, and then it would flip to the denominator. So I'm going to do that and copy down the rest of the problem as is. So it'd be 3 over 2 minus 3. And then the 6 to the negative first power, I would flip that 6 to the denominator, and it would become a positive first power, but I don't need to write that. And then since there's nothing left in the numerator, I would just have a 1 left there, and then plus 5. And then now with order of operations, we have subtraction, multiplication, addition. So multiplication would come next. So we have to multiply the 3 times 1, 6. Hold on, I'm going to cover up these lines just so I can keep writing over them. Okay, so we can go ahead and multiply the 3 times the 1, 6. So I'm going to bring down the 3 halves. And then the 3 times the 1, 6, if I want, I can think of this as 3 over 1, and then I can cross cancel a little bit. So like the 3 and the 6 are both divisible by 3. So if I divide them both by 3, this would become a 1, and this would become a 2. And then they're fractions, so I can just multiply straight across. So I would do 1 times 1, which is 1, and then in the denominator, it would be 1 times 2, so 2. So 3 times 1, 6 simplifies to 1/2, and then bring down the plus 5. And then now I just have subtraction and then addition, so I just go left to right. So I would have to do the 3 halves minus 1/2 first, which is kind of nice because they already have a common denominator of 2, so I don't have to really do any work there. I can just do 3 minus 1, which is 2, over 2, the denominator stays the same, and then bring down the plus 5. And then now the 2 over 2 kind of incorporates something that we need to go back and reduce. So 2 over 2 is just 1 plus 5. And then now we can finally add the last two. 1 plus 5 would give us 6. So the final answer for number 3 should be 6. And then last one for number 4, what is the value of the expression in the eighth root of 81, to the second power divided by 2 cubed to the 1/2 over 2 to the 1/2 minus 1 divided by 2. Okay, so I'm just going to go ahead and write this problem down here because it feels like I'm going to need a good amount of space. Okay, so I'm gonna start. So we have like grouping symbols, and then we have rational exponents, we have radicals, we have a whole bunch of stuff going on. I think I want everything to be in fraction exponent form. I definitely want this to be in fraction exponent form because I want to use the quotient property eventually, not right now, but I want to use the quotient property where you subtract the exponents. And then I want this to be in a fraction exponent form so that I can use the power property where you have like a power to another power. So I'm going to go ahead and change that. Let's see. So I'm going to change that 81, the fourth root of 81 first, into a fractional exponent. So the root is 8, my base is 81, my exponent is 2, so if I go ahead and I rearrange that whole thing, it would be 81 and then raised to the 2/8. And then over here, I'm just going to copy down the next step, so it would be 2, or sorry, copy down the rest of the problem for the next step, so 2 to the third power to the 1/2 over 2 to the 1/2 power minus 1 divided by 2. I have a fraction over here that I can reduce. So if I wanted to reduce that, I would divide these both by 2 on the numerator and the denominator. So then it would become 81 to the 1/4 power. And then divided by, I'm going to go ahead and simplify these exponents now just to avoid having to rewrite the problem too much. So over here, I have a power raised to another power. So when that's the case, I have to multiply the exponents. So I'd have to do 3 times 1/2. So this would become 2 raised to the 3/2 power. And then over 2 to the 1/2 power, that stays the same. And then minus 1 minus 1 divided by 2. And then for the next step with the 81 to the 1/4, there's a couple different ways that you can approach this. So for the sake of not having to change it back into radical form, I'm just going to rewrite 81 as a power, and then I'll show you the alternative way kind of off to the side after I do that. So like 81 is 3 to the 4th power. Like if I were to make a factor tree for 81, I could do 9 times 9, and then each 9 breaks down into 3 times 3. So that means that 3 to the 4th power, because I had 1, 2, 3, 4 threes, is equal to 81. So I'm going to go ahead and I'm going to take that 3 to the 4th power and I'm going to replace the 81 with it because I'm starting to recognize that there's a pattern between like the 4th power and the 1/4 power. So I'm going to swap that 81 out for 3 to the a fourth, and then that's being raised to the 1/4 power. And then I'm going to go ahead and simplify this fraction as well. So I have a quotient with the same base, 2 and 2, so I can subtract the exponents. So this would become 2 to the 3/2 minus 1/2. And then I'm going to copy down the rest of the problem. So minus 1 and then divided by 2. And then over here, I have another power to a power, so I would have to multiply those exponents again. But if I multiply 4 times 1/4, if I just multiply straight across, it becomes 4/4, which is just 1. So this would just become a 3 to the first power, or just 3. And then divided by, if I subtract here, I already have a common denominator, so I just need to subtract the numerator. So 3 minus 1 would be 2, and then the denominator stays the same, so 2/2. But 2/2 is just 1, so this would just be an exponent of 1. And then if I just have an exponent of 1, I don't need to write it, so I can just leave it off. I'll copy down the rest of this problem, so minus 1 divided by 2. And then now I just have like a bunch of nice little, like kind of regular numbers. Okay, so we have division and subtraction left. So we'll have to do division first. We'll go left to right. So it'll be 3 divided by 2. If you would like to change it to a decimal at this point, like plug 3 divided by 2 into the calculator, that is totally fine. I'm just going to write it as a fraction though. So 3 divided by 2 is 3/2, just 3/2. And then I'm going to copy down the rest of the problem. So minus 1 divided by 2, and then I have one more division that I have to take care of before subtracting. So I'm going to bring down my 3/2, and then 1 divided by 2. Same thing, if you wanted to put it as a decimal, you could, or you could just write it as a fraction, 1/2. And then now I just need to, now I just need to subtract my fractions, and they already have a common denominator, so I just need to subtract my numerator. So 3 minus 1 is 2, and the denominator stays the same, so it's 2/2, and then 2/2 is 1. So the final answer on this one, let me zoom out so we can see the question. The final answer for workbook 5.3 number 4 was 1. Okay, and then I'm gonna backtrack a little bit just to show you like the alternative thing that you could have done from here to here. So the alternative, instead of doing that, is you could have changed that 81 to the 1/4 back into a radical. So if I had done that, and I'm just gonna kind of write this like off to the side. So this would be my b to the e over r. So that would mean the 81 would go inside of the radical, and then the r would be 4, and then the exponent would be 1, but I don't need to write that. And then we already talked about over here how the 3 to the 4th power is 81, so that means that the 4th root of 81 is equal to 3. So I would take that 3 and it would replace it. And that's the same thing we got over here. So you would still end up getting like the same answer. So that's kind of like the beauty and the hard part about these problems is we could all do these problems like a different way and still end up at the same final answer.